Okay, so we start after the break. So now we are learning about the user agents. So user agent that communicates using HTTP can referred as a user agent. So RFC 321 32 sorry 7231 suggests that user agent should be use the user agent header to identify themselves. So in every request, what goes in there is up to the software that makes the request. So through using comprises a string that identifies the program and the version. So possible operating system and hardware that it's running. For example, the user agent of current version of Firefox is shown like this: Mozilla 5.0, X11, Linux, blah blah blah, and the further about the this agent. Okay. So although it has been broken over two lines here, it is single long string. As you can probably decipher, I am running ICE level Debian version Firefox version 24. So it is regarding the this information, which is from the book again. So if you are trying to learn about your agent, so you will get whatever browser you are using, and you can get this information using the following the remaining. So the user agent string are not intended for identify individual users. Just try to understand this. This is the intention is to facilitate the user. Like suppose if you are using a mobile browser which does not support the big, so server will send you a web specific to your mobile browser. If you are using some the Windows or Apple or whatever, so that is the specific reason. So and the only identify the product that used for making the request. So we can view the user agent that user lib uses. So user, what is user lib? This is a Python package. So for the request, we just generated python.org URL open req request get header user agent. So now we get our Python URL lib 3.4. So here we have created a request and submitted it using URL open. So and URL open added the user as an header and the request, and we can examine that header using the get header method. This header and its value are included in every request made by the URL lib package. So every server we make a request can see that we are using a Python 3.4 and user lib library, right? So webmasters can inspect the user agents of request and use information for various things, including the following. So classifying the visits of their websites. As I mentioned that some people they are using the web scraper or web crawler, blocking clients with certain user agent strings. Maybe you can block your the specific agents. Sending alternative versions of resources of users known as problems such as bugs when interpreting certain languages like CSS or not supporting some language as well, such as JavaScript, right? So that is also important. So the last two can cause problem for us because they can stop interface with us accessing the content we are after, right? Suppose we want to create a Python program to crawl the web, and if the specified user agent, which is the user lib or Python version, they might block us, right? So what is for this? So to work around this, we can try to set our user agent that is mimics a well-known browser, and known as spoofing. You have read this concept of spoofing? No? Pretend to be someone which is not right. So now we are Python URL lib, but we are pretending to be some other user agent. So now what you can do, You can do request this and read and header user agent. Now we are sending our user agent differently. So we are identifying Mozilla 5.0, blah, 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 all this detail which is for the Mozilla web browser and Linux operating system, and now response requests. So the server will respond all in our application regular Firefox client, right? You might have noticed in your mobile phone as well when you are using a web browser and some of the web is not opening properly. So you might have seen three tabs on the right, and you might have seen this option of view as desktop. Anyone notice this option here in the browser? Desktop. We view as a desktop web. So basically, what are you doing? You are changing your request. You are not sending the user agent as a mobile browser. Now you are sending to the web server that I am a desktop. Send me the desktop version of the web. So that's what we can do using the Python. Defining this, we can just pretend to be Mozilla Firefox, or we can pretend to be, the Windows Edge browser or whatever browser. So different browsers are available on the web. So I'm yet to come across a comprehensive resource of them, but Googling a browser and version number usually will turn up something, and actually you can use the Wireshark to capture the HTTP request, which we already done. So we can just capture the HTTP request on Wireshark and detail header. We can find the browser, the details, and we can copy paste here and send it as our Python client. So we can pretend to be that specific web browser. Okay. So cookies. Anyone has idea about cookies? Chocolate chip cookies? No. What is cookies? Concept of cookies in the HTTP or web? Mm-hmm. Yes, very good. So the cookie is a small piece of data that the server sends as a set of cookie header and is part of the response. So the client stores cookies locally. So basically the client stores cookies. Server is not maintaining the cookies. It's just sending you a specific ID sort of for your cookie. So that include them any future request and send to the server. So basically, the server uses the cookies in various ways. They can add a unique ID to them, enable them to track the client and access different areas of the website. They can store login token, which automatically logged the client even if the client leaves the site and access later. And they can also use for the storing the client's user preference, snippets, personalization information, blah, blah, blah. And cookies are necessary because the server has no other way to track the client request. HTTP is called stateless protocol. That is very important statement you need to learn. What is stateless protocol? It has no states like Sabah, Selangor, no state. No? What is stateless protocol means? Stateless protocol means the HTTP or basic web protocol does not record your information. Like suppose how many times you access the web, it will not. You mentioned in the previous section, I told that some of the browsers they create multiple sessions, multiple TCP connections. And the web server by default does not stop it because there is no way to record that it is the same person coming again. Because web server does not create any record of your information other than cookies. Cookies is a different thing. Cookies is not basically basic HTTP protocol. It's addition on this. So basically the stateless means whatever time you make connection, it will consider you a new client to making a TCP connection. So anyone knows how DDoS attack created on the web? DDoS, distributed denial of service attack. So basically, there are two types of attack. The attack you are talking about, it's sort of, the creating a lot of devices, your slave, and then generating the attack. But it can be generated by one device or many devices. And specifically, web DDoS attack is just to create a TCP connection, multiple thousands of TCP connection, and left them open. So what happens? The genuine request come for HTTP, it will not get chance because the server is occupied by the TCP unwanted requests. So that's the problem. So that is the feature which is called stateless. So it does not contain explicit mechanism for the server to know sure that two requests have come from the same client. So without cookies to allow the server to add some unique identity information and request and things such as shopping cart, right? You know that sometimes you do not create a login and you start clicking some or liking some products on some of the, the online web purchase, and it goes to your cart, and you go back and you see that they is still in the cart, but you still did not create the login. So that's how they maintain through the cookies. Once you create your login and you try to proceed, then it will just pass to this your login. Okay, so would become impossible to build. So this cookies feature is totally separate from the web server. So basic web does not come with the cookies, but for the cookies they maintain a database, they maintain your records. Okay, and all this happens because of the cookies. What happens? You just create one login of your, the Gmail, and you just start saving all this in your browser. And when you go to your specific web, most of the time it does not ask you to re-login. It does not ask you for the, put the login and password. Why? Because it's just checking your cookies. It is from the same system, same specific, and then it's verified and make you login. So we may need to handle the cookies using Python because without them, some site does not behave as expected. Okay. So when using Python, we may also want to access the parts of the site which require a login, and login sessions are usually maintained through the cookies. Okay. So some websites require login, and if we want to use the Python client, so we must know how to use this. So handling the cookies. So we are going to discuss how to handle the cookies with URL lib. First, we need to create a place for storing the cookies that the server will use. So from now we import http.cookiejar, import cookie jar. Okay. So now we define cookie jar, cookie underscore jar is equal to cookie jar, and then next we build something called URL lib opener. This will be automatically extract the cookies from the response that we received and then store them in your cookie jar. So from URL lib.request import URL opener HTTP cookie processor. Okay, so opener is equal to build opener HTTP cookie processor, and we define cookie jar. So then we can use the opener to make HTTP request. So opener.open, and when we use the GitHub. So lastly, we can check the server that sends. So len.cookiejar. So it will tell you how many cookies in the cookie jar. So you access multiple websites which create the cookie. So you will see that the cookie jar has more cookies. So when we use the opener to make further requests, the HTTP cookie processor functionality will check our cookie jar to see if it is contain the cookie for that site, and then will automatically add them to our request. It will also add any further cookies that are received to the cookie jar, right? As I just mentioned. So the http.cookiejar module also contains file cookie jar class that works in the same way as cookie jar. So, but it provides an additional function for easily saving cookies to a file. So this allows persistence of the cookies across Python sessions. So know your cookies. So now we are going to explore our cookies. So it's worth looking at the properties of the cookies in more details. Let's examine the cookies at GitHub we sent. So to do this, we need to pull cookies out of the cookie jar. The cookie jar module does not let us access them directly, but it supports the iterator protocol and a quickly way to getting it from. So cookie is equal to list cookie jar, then we write cookies, so we get the cookie version, name, login, then cookie version, all these details. So these two cookies are available. So you can see that we have two cookies objects. Now let's pull some out. One, so cookie 0 dot name. So name is logged in. Okay, and cookie 0 dot value. So value is no. So what this information is, the cookie's name allows the server to quickly reference it, right? So the cookie is clearly a part of mechanism that GitHub uses for finding whether we are logged in or not. Let's do the following. So we just write the cookie 0 dot domain. So we get that this is from github.com. So through the domain we know that what cookie it is, cookie 0. Then we follow the cookie 0 path, so we will know that this is slash. So after the github.com, then the path is slash and then this cookie. So the domain and the path are the areas which the cookies are valid. So URL lib opener will include these cookies in any request that is sent for the github.com and its subdomain, whether the path is anywhere below the root. So now look at the lifetime of the cookie. So cookies 0 dot expire. So we will get this information. This is a Unix timestamp. We can convert it to timeline. So we just use a module import time date time, and then date time dot format times stamp, and we just write cookies dot expire. So we will get this date timeline in this format, which is, so our cookies will expire on for specific this stamp. If you try at your end, you will get different dates and different time stamp, and you can just see that this is expiring on 22nd April of 2035, and an expiry date is the amount of time that the server would like to client to hold on to the cookies, and once the expiry date pass, the client can throw the cookie away and server will send a new one with the next request. Of course, there is nothing to stop a client from immediately following a cookie away. Obviously, if you just throw away, like suppose when you clear the browser and delete the cookies, so when you access next time, it will generate a new cookie, right? So that is why it is advised if you are using someone else's PC and you use your, the credential, and so when you are deleting the history, also delete the cookies, so that no one can use your login using the cookies. Okay, so now let's we discuss two common flags for the cookies. So print cookies get non-standard attribute HTTP only, and the response will get none. So what it is, cookies that are stored on a client can be accessed in a number of ways. So by the client as a part of HTTP request, a response, or by script running client just such as JavaScript. So by other processes running in the client such as Flash. So HTTP only flag indicate that the client should only allow access to the cookies when the access is part of HTTP request. Right? Suppose if it is mentioned HTTP only, then you cannot run the JavaScript, you cannot run Flash or something else. Okay. So the other method should be denied access. So this will protect the client against cross-site scripting. Anyone has idea about cross-site scripting attack? No. So basically what happens, you are redirected from some of the web, and using your cookies, someone will steal your thing. It's not time to discuss in detail, but if you are interested, you just search cross-site scripting and you will get a lot of material and you can read it. Okay, we will discuss in chapter 9, it says. So when we will discuss the web application, we will discuss. For more information, the important security features, and when the server sets it, our application should behave accordingly. So now there is a source flag. So what is cookie.secure? Sorry, secure flag. So it says true. So if the value is true, the secure flag indicates that the cookie should only ever be sent over a secure connection, such as HTTPS. Anyone has idea about HTTPS? Secure, and how it makes secure? Basically, the plain HTTP, just simple HTTP is plain text. So if anyone, like suppose if you are using Wireshark in this room and you capture my packet, so you can just read the HTTP packets. It's plain text. But if you are using HTTPS, it means it's secure. Secure means it encrypts all the packets sending and receiving. And server also send you encrypted packets. So the request contain a cookie, it's only send them on HTTPS URL. So you may spotted that inconsistency here. Our URL has requested a response over HTTP, yet the server has sent a cookie, which it's requesting to be sent only over the secure connection. Surely the site designers did not overlook a security loophole like that. Rest assured that they did not. The response was actually sent over HTTPS. So suppose we just tried to use this cookie and it says, oh, true, but basically the response came was using the HTTPS because it already communicated directly. So what happened? Well, answer lie in the redirection. So now what is redirects? So suppose how we just sent a request using simple HTTP, but the server is using HTTPS and it replied using HTTPS. How it possible? So now we come to the next point, which is called redirects. So sometimes server move their content around, and they also make some content obsolete and put a new stuff in different locations. So sometimes we would like to use, we like us to use more secure HTTPS protocol instead HTTP. All these cases, they get traffic that asks for the old URL, and in all these cases they would probably prefer to able to automatically send visitors to the new ones. So the 300 range of HTTP status code is designed for this purpose. So these codes indicate the client that further action is required on their part to complete the request. The most commonly encountered action is to retry or request at a different URL that is redirected. So sometimes they return a response with the new URL that this website is or this is moved. So we will learn how it works when we are using the user lib, URL lib. So request, REQ request is equal to gmail.com. So we are accessing the gmail.com response URL open request. Simple enough, but now we look at the response. So request is response.url. So you get this long response, this URL, accounts.google.com, blah, 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 all this. So this is not URL that we requested. We just requested gmail.com, and in the response we are getting accounts.something, right? So what it is, basically it is redirected. So if we open this new URL in a browser, then we will see that it is actually the Google login page. So you may need to clear the browser cookies if you directly log in, but if there is no cookies, then it will be basically user login page. So Google will redirect us from the gmail.com to its login page, and URL lib automatically follows the redirect. Moreover, you may have been redirected more than once. Look at the redirect underscore dict attribute and our request. So when we write request req dot redirect underscore dict, so we will get this response that we redirected from here and redirected from there. So the URL lib package adds every URL that we redirected through this dict, and we have actually redirected twice. First from gmail.com sent to the second login page. So when we send our first request, the server sends response with the redirect status code. One is 301, 302, 303, or 307. So all of these indirect or redirect. So this response includes a location header which contains new URL. URL lib package will submit a new request to the URL. And aforementioned case, if we receive another redirect, which will lead to the Google login page, right? So what happens in the response? It will give you the new URL. So our user lib directly connects to the new URL. So since URL lib follows redirects for us, they generally don't affect us. But it's worth knowing that a response URL lib returns may be a URL different from what we had requested. So also if we hit too many redirects of a single request, more than 10 for URL lib, then URL lib will give up and raise a URL lib error, the HTTP exception. If it's redirected 10 times for the same URL, so it will not follow all the redirects and it will give up. Now URL, Uniform Resource Locator. So URLs are fundamental for any way which the web operates. So we have normally described in RFC 3986, all URL presents a resource on a given host. How URLs map to the resource on the remote system is entirely at the discretion of system admins. So URLs can point to files on the server. Resources may be dynamically generated when a request is received, and what the URL maps to through doesn't matter as long as URL work when the request them when we request them. So URL are comprised of several sections. Python uses URL parse module working with the URL. Let's see, Python breaks a URL into component parts. So suppose from URL lib parse, import URL parse. So result is URL parse, and then we write this Python /dev/paps. So then results. So what is the results? Parse result scheme HTTP netlock python.org. So important point is just you understand that the netlock is basically the domain. The path /dev/paps palms is equal to query is equal to fragment is equal to, right? Suppose so we just so the URL lib parse function interprets the URL recognize HTTP as a scheme, www.python.org as the network location, and dev/paps as a path, and we can access these components as attributes of the parse results. So these all things are we can access. Okay, so for almost all resources on the web, we will be using HTTP or HTTPS scheme. In these schemes, to locate specific resources, we need to know the host that resides on the TCP port and should connect together. These are the netlock or network location component. So we also need to know the path or the resource of the host, that is called the path component. So port numbers can be specified explicitly in the URL by appending them into the host, right? So they are separated from the host by the colon. Let's see what happens. So when we parse, so suppose URL parse http python.org colon 8080. So this 8080 is basically the port number. So parse result scheme http net location python.org colon 8080. So the port number is, you see this part of the net location. then path is forward slash, and the rest is just so URL parse method just interpret it as part of the netlock, and this is fine because it's how handlers such as user lib request dot open accept is formatted. So if we don't supply a port as is usually in the case, so then by default it's 80, which is for the HTTP, and the default port 443 is used for HTTPS. Okay, so this is usually what we want as we standard ports and the HTTP and HTTPS protocol. Sometimes people use some other, the other than HTTP and HTTPS, but usually these ports. So path and relative URLs. So path in a URL is anything that comes after the host and the port. So path always start with the forward slash, and when the slash appears on its own, it's called the root, right? So suppose if just the slash, forward slash, it means the root. So we can see the performing the following. And all it's, if you remember that in the first or second lab, I tried to create Apache server, and we just created an index.html file. So you remember the location of this file that was in the www folder, and whatever folder you create there, those will become the paths like slash. So that's why these are just interpreted in the web like the paths. So suppose URL parse, we just write python.org, result will be the scheme HTTP, HTTP log Python, and the path is forward slash, which means root, right? So no path is supplied in the request, then the default user lib send request is the for the root. So when a scheme and a host are including a URL, as in the previous example, the URL is called absolute URL. So like suppose in previously it's absolute URL. Conversely, it's possible to have relative URLs which contains just a path component as shown here. So URL path something dot dot slash images slash tux dot png. So parse result is netlock is nothing here. Path is dot 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 images slash tux dot png. So that's the response. So we can see that parse result only contains a path, and if we want to use a relative URL to request a resource, then we need to supply the missing scheme, the host and the base path. Usually we encounter relative URL in a resources that we are already retrieved from a URL. So we can just use the resource URL to fill the missing component. Let's look at this example. So suppose we have retrieved debian.org URL, and within the web resource code we found relative URL for about page. So we found that it's relative URL intro slash about, right? So we are discussing about this website debian.org, and we found some page which is relative URL intro slash about. So now our Python, the user lib should URL lib should combine them, otherwise that URL will be invalid. So we can create absolute URL by using the URL of the original page, URL parse.url join function. So let's see how it can do so. From URL lib parse, import URL join. Now we provide this absolute URL and the relative URL. So the result will be this complete URL path. So by supporting URL join with the base URL, the relative URL, we have created a new absolute URL. And that is very important for the this Python programming, because a lot of places they will find the relative URL. So then it has to combine. Hence, we notice that how URL join has filled the slash between the host and the path, and only time when URL join will fill this slash for us when we provide the base URL does not have the path. As shown by the preceding example, let's see what happens if we does not have base URL in the path. So suppose URL join Debian slash intro slash and then about. So you see that it does not provide another slash because it's already here. So URL join. No, sorry. We just provided this and we just, oh, sorry. In the first part, you see that it joined with the about, but in the second part, you see after the intro, there is no slash. So what happens when we join, it will discard the intro and it will put on the base URL about. You see the difference? It's just because of this slash. So if it does not find, so this will give us varying result. Notice how URL appends the path. If the URL base ends with a slash, but it replaces the last path element in the base URL, if the base URL does not end with the slash. Okay, both different things. So it's very important to define the path complete. We can force a path to replace with the element of a base URL by prefixing it with the slash. Do not following. Suppose URL join, here you see in the end there is no slash, but for the relative URL we define slash dash news, right? So in the result is it's just because there is no slash defined, so it will just add to the direct root. So how about navigating a parent directory? Let's try to the standard dotted syntax as shown. So now we are using a dotted syntax. So you see that it will join the news into the intro. And suppose if we like this, so it will go to the root. So it's, if you have used the Linux, we use the dot, right? So it's inverted the dots before. So it's all the way. If you just put command cd space 2 dots, so it will go to the one, or if you press the cd space 1 dot, it will go to the root, something like this. And then suppose if you provide about and dot news, so it will go to the new. So we just it works as we would accept into. So note the difference between the URL base having and nothing trailing slash. So let me what if relative URL is actually an absolute URL. So URL join, and you see, so when we provide these two, and so we will get this. So relative URL completely replaces the base URL because this is a complete URL. So this is handy as it is means that we don't need to worry about testing whether URL is relative or not before using the join URL. Okay, so I think I need to complete one more topic and then we will finish. So query string. So RFC 3986 define another property of URLs that can contain additional parameters from the key value pair appear after the path. So they separated from the path and a question mark as shown here. So like suppose docs.python3.org/3/search.html question mark, then q, and then after is equal to URL parse and area default. So this string of parameter is called a query string. So multiple parameters are separated by ampersand. Let's see how URL handles it. So URL in the bracket we just write the the search.html question mark, all this URL we just saw there. So parse result scheme HTTP netlock, you see this is the base URL, then path, this is the path, and parms and query is q is equal to URL parse ampersand area is default. So the URL parse recognize that query string as a query component. So query strings are used for supplying parameters to the resource that we wish to retrieve. Anyone has tried this before? Like suppose some of the Google search, you might have seen that when you put some simple words, so that goes in a URL. Anyone notice this? When you put result, suppose you search Apple, so when you enter, you see that your URL containing the Apple in the query. So that's how this query string works. So use supplying parameters to the resource that are with the retrieve, and this usually customized to resources in some way in aforementioned example, and query string tells the Python doc search. So basically this will search and term URL phrase. So URL if the parse method has the function that helps to turn query component returned by the URL parse and something more useful. So from URL parse import parse underscore QS result is URL parse. So you see that uh, all this code will return us the parse underscore QS method reads the query string that converts it into a dictionary. So see how dictionary values are actually in the term of list. So this is because the parameters can appear more than once in query string. So try with the separated parameters. So results URL parse, and we will send this query URL parse ampersand q is equal to URL join. So parse underscore results, and you will see this URL parse and URL join. So see how both of the values have been added to the list, and it is up to the server to decide how to interpret this. And we send this query string, then it may just pick up the value and use that, and ignoring the repeat, or it can try to see for what happens. So can usually figure out what you need to put in the query string for a given page of submitting the query through. So web interface using your web browser and inspecting the URL of the results page. You should be able to spot that text in your search and consequently, the deduce a corresponding key for the text search. Quite often, many of other parameters in the query string are not actually needed for getting a basic result. Try resulting the page using only such text parameters. See what happens. We just try to Google search and we will see what happens. And if it does not work as expected. So if you submit a form to a page and resulting page URL does not have a query string, the page would have used a different method for sending the form data. We will look into this HTTP methods later, and we discuss the post method. Okay, so I think for today that's it, and we will having this little bit more we will complete in later class.